Hello everyone. In this international conference on Radioscience, Equatorial Atmospheric Science and Environment in Greece, and the 6th Asia Research Node IRN Symposium on Humanosphere Science, I will talk about evaluation of GPM IMERG products for extreme precipitation over Indonesia. My name is Ravidho Ramadhan, and this is the list of authors that contribute in this research. Extreme precipitation, both extremely wet or extremely dry, frequently followed by hydrometeorological disaster such as floods, landslides, drought, and forest fires. So we need accurate spatial and temporal information of extreme precipitation for forecasting and disaster mitigating. A high spatial resolution of extreme precipitation measurement can be obtained from satellite observation, but this measurement is need to be evaluated. One of products of precipitation satellite is integrated multi-satellite retrieval or IMERG from global precipitation measurement satellites or GPM. So, this research evaluates the GPM emerging products for extreme precipitation over Indonesia because Indonesia has a high potential of extreme precipitation. This work evaluates GPM emerging include early, late, and final products to detect extreme precipitation using rain gauge observation of Indonesia from 2016 to 2019. Hourly precipitation data were provided from Indonesia Agency for Meteorology, Climatology and Geophysics (BMKG), and we only considered rain gauge observation with more than 3 years of complete observation. Complete observation is defined by an annual observation rate above 90%. And you can see in figure 1 the spatial distribution of 23 gauge observation and emerging grid. The elevation data is from GEPCO data. And the evaluation was carried out by comparing extreme precipitation index from the expert team on climate change detection and index ATCCDI. And this is the 12 extreme index from ATCCDI used in this study. And we classified the class of index to 4 class. The first class is identified the precipitation amount, precipitation duration, precipitation frequency, and the precipitation intensity. Okay, this is the result of this research, and the first is about evaluation of precipitation amount based index. We include 3 index, that is precipitation total, R 90 percentile, R 95 percentile. So evaluation found that highest value of precipitation total during 2017 and the smallest was identified during 2019. This pattern coincides with La Nina and El Nino modulation. This different pattern affected to be the different number of disasters in Indonesia. According to Indonesian National Board for Disaster Management or BNPB, you can see in this slide there is a small difference from the flood and landslide, and the highest difference from drought and forest fire from La Nina and El Nino observation. And you can see the IMERG shows overestimation value for precipitation total and shows under estimation value for R 90 percentile and R 95 percentile index. The 3 IMERG data types shows good agreement with rain gauge and has slightly different from both early, final, and late products. And the second is about evaluation of precipitation frequency, including R1 millimeter, R 10 millimeter, R 20 millimeter, and R 50 millimeter. A significant difference of the value of frequency-based index was observed from R1 millimeter and R10 millimeter. R1 millimeter and R10 millimeter show a similar pattern with precipitation total that I told before. Its pattern explains the insignificant number of floods and landslides between 2017 and 2019 during La Nina and El Nino modulation. R1 millimeter and R10 millimeter show overestimation value, while the R10 millimeter and R50 millimeter shows underestimation value. That's accordance with R90 percentile and R95 percentile index. Okay, we continue to the next. This is the evaluation of precipitation duration. We analyze this index with consecutive wet days or CWD and consecutive dry days, that is CDD. CWD is not significant different during La Nina and El Nino years, coincide with insignificant number of floods and landslides between both years. CDD shows significant increasing number during El Nino that coincide with the higher numbers of drought and forest fire in Indonesia during these years. Overestimation value was shown from CWD index and underestimation value was shown from CDD index. Overestimation from IMERG is probably due to the high false alarm ratio, the highly regional variation, and the limitation of rainfall detection of rain gauge 0.2 millimeter. This rain gauge only can detection rainfall from in limitation of 0.2 millimeter. Evaluation of precipitation intensity index was analyzed from annual maximum 1-day precipitation or RX 1 day, maximum 5 days precipitation RX 5 days, and simple daily intensity index or SDII. RX 1 day and RX 5 days index show significantly different as compared to the SDII index. SDII index that shows a uniform pattern for all years when the precipitation total value changes significantly. It is probably due to the accumulation of extreme precipitation on certain days not spread throughout the years, consistent with CWD pattern that's not significant different. An underestimation value from IMERG was obtained for all precipitation intensity based index. In addition, all three IMERG run data types shows different values, and this is the and we analyze the total flows even from the NPB data for seasonal, intra-seasonal, and interannual modulation. Actually, there are some variation that modulate the occurrence of total floods occurring in Indonesia. That's most of floods influenced by extreme precipitation. So the evaluation of emerging product for extreme precipitation of Indonesia is not final yet, and we will analyze the modulation of seasonal, intra-seasonal, and interannual modulation, and this is still progressing, and the result will submit soon. And conclusion, overestimate value for extreme precipitation index were dominated by low intensity precipitation, such as precipitation total R1 mm and CDD index. On the contrary, underestimation values of extreme precipitation index dominated by high intensity precipitation such as R90 percentile, R95 percentile, R50 mm, and RX 1 day index. Moreover, the different types of emerging data show a similar pattern with slightly different values for identifying extreme precipitation index. So, a more comprehensive study is needed to improve GPM emerging in observation the extreme precipitation over Indonesia. And this is the last slide from my presentation. So I say thank you to